Here's an overview of these core computer concepts. Logic of a computer. Computers operate on binary logic, meaning all data is represented by ones and zeros. This binary data flows through circuits in the form of electrical signals, where different voltages represent on, 1 and off, 0. The core of a computer's operation involves processing these binary signals to perform calculations and make decisions using logic gates and circuits. Computers use a combination of binary arithmetic, addition, subtraction, etc., and logical operations, and, or, not, etc., to execute instructions. These instructions are stored as a series of binary numbers, which the computer processes step by step using its central processing unit, CPU, and other components. Principle of a transistor. A transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. It's essentially the building block of modern digital circuits and serves as a tiny switch that can control the flow of current. The transistor has three parts: base, the control terminal; collector, where current flows in; emitter, where current flows out. In digital electronics, the transistor functions as a switch. By applying a small voltage to the base, you allow a larger current to flow from the collector to the emitter. This switching mechanism allows transistors to create binary states, on and off, in logic circuits, thus forming the basis of computer logic. Basic logic gates. Logic gates are simple electronic circuits that perform basic logical operations on binary data. Here's how the three fundamental gates work. NOT gate. A NOT gate, also called an inverter, takes a single input and outputs the opposite value. If the input is 1 on, the output is 0 off, and vice versa. AND gate. An AND gate has two or more inputs and produces an output of 1 only if all inputs are 1. If any input is 0, the output will be 0. OR gate. An OR gate also has two or more inputs and produces an output of 1 if at least one of the inputs is 1. The output is 0 only when all inputs are 0. These gates are combined in complex circuits to create everything from basic arithmetic operations to decision-making processes in computer processors.